Okay, we're going to do the demonstration, which is after 4.1, activity 4.1 on your packet. And for the demonstration, what it says is the teacher will now charge a capacitor with one battery pack, as in figure 4.1a, then add a second battery pack, as in 4.1c, and then we're going to add a third battery pack. How many times will the bulbs light? All right, so do you think that the bulbs are going to light 3 times? In other words, will I still be able to add more charge after the second battery pack has charged the capacitor? So let's check that out now. So first of all, I'm going to discharge this thing because I have already charged it up when the camera wasn't running. So I discharge it. All right, did you notice that little spark? That was kind of cool. All right, so I'm going to start with one battery pack and see what happens, right? Nope, sorry, that's nothing. We're going to start with one battery pack in the circuit. Bulbs light up and then they stop. Now we're going to charge it with a second battery pack. They light again, so it can take charge from 2 battery packs. Now we're going to add a third battery pack into this. Again, we're going positive to negative side. What's going to happen? They're going to light again. Can the capacitor hold more charge? They light up, and then they fade. All right. Now, notice that each time the light bulbs light up, and then they fade and stop. So number 8 here says, why do you think bulb lighting stops each time? So I want you to think about that and then write down your answer. And by the way, let's take a look at what happens now when I discharge it. So let's take the battery packs out of the picture and hook it up. Oops. Oh, there we go. Had a bad connection. Look at that. Look how long they lit that time. All right, cool. All right, now after the demonstration, after you answer number 8, I just want to talk a little bit about the concept here that we're seeing. It's almost like, so when you look at why the light bulbs stop lighting, it's almost like as we're charging it, first we're able to put in a lot of charge, and then the amount that we're able to put in kind of fades off. It's almost like there's pressure building up. So think about it like this, and this is under commentary when it talks about the electric pressure idea on page 42. Compare the extra charge being pumped into a capacitor plate by a battery with extra air being pumped into a tire. As charge flows in, the concentration of charge in the plate increases. You can imagine the charge in the plate being compressed to make room for more, like air in the tire being compressed to make room for more. So as I hook this up to the batteries, I'm essentially pumping charge into this side of the plate that is inside of this can here. I'm pumping charge into this plate. And then they ask a question here. Does compressed charge try to expand back out of the plate through a wire, like compressed air expands back out of the tire through a hole? If compressed charge behaves the same way as compressed air, then the following events will happen. As the capacitor is being charged, energized, the energy per charge in the capacitor approaches the energy per charge in the battery. Increasingly strong reverse pushing by increasingly compressed charge in the plate will make the battery less and less able to pump more charge into the plate. That will make the bulbs get progressively dimmer during capacitor charging. And when the battery is removed, compression in the plate will push charge in the reverse direction and discharge the capacitor. Decompression will weaken the reverse pushing and make the bulbs dimmer over time during discharging. These bulb dimming predictions were in fact observed. The observations provide evidence that compressed charge in circuits really does behave like compressed air. Air pressure is the name given to the effort to expand by compressed air. The name electric pressure is the same effort by compressed charge. Electric pressure is measured in terms of a unit called the volt. named after the Italian scientist Alessandro Volta, who introduced the concept in 1778. So picture this. It's like we're pressurizing. We're compressing the charge on this plate right here. We're removing charge from this plate. And then when we disconnect the batteries, the pressure is pushing the charge back out in the opposite direction. We can tell it's the opposite direction because the needle deflects differently, right? Deflects in the opposite direction. Pretty cool.